Assalamu alaikum everyone. So let's start with our next topic, which is called as leveling. So in leveling, basically what we do is we either try to create vertical control over an area, or we might try to execute a project by carrying out a layout survey. So it could go either way, but what I mean by gaining vertical control or laying out points is that in the vertical plane that you need to find out relative height of points. So that means I need to find out vertical distance between different points or elevation difference between different points. So that is called as leveling. So there are a number of ways to find out elevation difference between 2 points. The simplest one would be by using a measuring tape or by using a scale. So if I start with a very simple example of a staircase and finding out difference in height. So a very basic thing that you can do is place a measuring tape or a scale over here, and we can determine the vertical difference between this step and this step. So this is very simple. But if now I wish to find out elevation difference of a ground which has a very haphazard sort of a surface, so then your measuring tape or your scale uh, does not give you much. It's very difficult for you to use a scale or a measuring tape to find out vertical elevations in the real natural scenario. So that gets very difficult unless you have a very geometrical sort of a plane. Then it's easy, but in natural terrain, it's very difficult. So this is where instruments come in. The surveying instruments come in, and one such instrument is called as an autolevel. We'll also talk about a couple of other instruments later on as well. But let's first talk about autolevel, or the basic leveling instrument that we will use. So that is basically an instrument that you place on a tripod stand, pretty much similar to like you did in compass surveying. And above that, you place the instrument. We go into details of the instrument later on. But what you get from the instrument is that it has a telescope attached with it, and when you look through the telescope, it magnifies your vision, and the vision that you get out of it is something like this: a telescopic vision with crosshairs in the center, and something like this. And what you are trying to view is a bigger version of a foot scale that is called as a leveling staff. So it is a staff that can extend to up till 5, 6, 7 meters, whereas the foot scales that you have probably cover just one third of a meter. So over here you have the similar graduations like you have on your foot scale that you use for basic stuff, drawing up stuff or measuring stuff, just like a measuring tape. So over here you have graduations. So when you look through the auto level instrument, you get a line of sight. So this is an imaginary line, uh, which is called as your line of sight or line of collimation. And when you're looking through this instrument, standing on one side, so what you're actually looking at is this crosshair with a telescopic vision, which magnifies it, and on the end of it, there you place this leveling staff. Now, when you look through it on the leveling staff, although the graduations are very small, but since it magnifies your vision, you get an enlarged view of these graduations on the leveling staff. So what you would be probably looking at it is a reading. So if your crosshair gives you this, and if this is 4 and this is 3 meters, so you'll probably be reading a value. Now, this value in itself doesn't give you much, but when you compare it with some other value, keeping your instrument at the same location, that is where it gives you elevation difference between 2 points. So let's say that I place my instrument over here, right? And I have this line of vision. So first I place my, and this has to be horizontal. Doesn't look horizontal when I do it, but this line of sight or your instrument has to be level, like you did in compass as well. So first you place your leveling staff over here, and let's say the reading comes out to be 2.62, whatever units. And then you place your leveling staff over here, and now the reading comes out to be 1.27, right? So now this is where you can gain some perspective or find out a difference between two elevations, the elevation difference. Since your instrument has the same location, it has the same line of sight, it doesn't change for the two observations that you just made. So what changed was the location of your leveling staff. So first you placed it on this step A, and then you placed it on this step B. And the first value you got was 2.62, and then you got 1.27. Now if I subtract from 2.6 to 1.27, this difference will be the difference in height between the point A and the point B. And how do you get this? Because the leveling staff starts from 0, and if the line of sight remains the same, so, and the leveling staff at two different locations gives different readings, it means that the 2 points are at a different height. Had they been at the same height, you would have got same reading on the staff on point A and the point B. But since they give you a different reading and the level or elevation of your instrument remains the same for the two readings, that means the 2 points are not on the same level or same elevation. And what is the difference in their elevation? That depends on the difference of the two readings. Simple. So in this case, if I don't draw this figure and I just give you these two values, so just by looking at the two values, you can see that which point would be at a higher elevation and which point would be at a lower elevation. Subtracting one from the other would give you the difference, but you can also judge that which one is at a higher elevation. So if your leveling staff gives you a bigger reading, what does that mean? That means that the point is at a lower elevation. So let me draw this again. So let's say I have a natural terrain like this, and I place my instrument right over here, right? And this becomes my line of sight. I want to find out elevation difference between these 2 points. In one case, I place my leveling staff over here. In the other case, I place my leveling staff over here. Now remember, the 0 for both starts at the base of the leveling staff. So the 0 is same. So for this point A, and I'll call this as point B. So for the point A, since the graduations are same, it's the same staff basically that you're using. So at the point A, you will get a smaller reading. And at the point B, you will naturally get a larger reading or bigger reading. So that means lower the point, higher the reading, right? So the difference between the two will give you the level difference, and the staff or the point which is giving you the bigger reading, that means that point is lower in elevation. And this is how this works. By using this instrument, you can quickly find out height difference between a lot of points. So if I have a very difficult terrain, I can just place my instrument at one location, and this becomes my line of sight, and I can find out heights of different points just by taking my staff, placing them at all the points whose elevation I want to know without moving my instrument. So this really speeds up the process of finding out height difference between different points. So once you have all of these values, what you can do is you can draw the profile of the land, and not just the profile. You can use it to find out water carrying capacity of a valley. You can find out a number of things. Let's say you want to you want to build a road in a terrain that looks like this, and if you have this profile of the land, you can decide on the grade of the road and the elevation of the road, because you have different options. I can build my road over here while the ground is over here. So that means I'll have to fill up this entire area. On the other hand, I have an option to construct my road over here. That means I'll have to excavate all of this soil. So that's another cost. And another option is to select a profile in such a way that whatever soil or ground I excavate, I'll use the same one to fill it up where filling needs to be done. So that really economizes the project, and that is how you can use leveling as a very powerful tool to execute your projects. Similarly, whenever we construct roads at a grade, or water supply lines or sewerage lines, they have to be at a specific grade or a slope, so that naturally the liquid inside can keep on flowing at a speed that you decide on depending on the slope. So if this is my land and your supply pipes are usually below the ground, and I, I have decided on a slope, so now I need to excavate. And how much to excavate? I can use my level by first on paper finding out these excavation heights, and then I can use my instrument to go in the field and actually find out those depths. So it helps in not only control survey, but it also helps in execution as well. So this was all about finding out relative height difference between 2 points. Usually we use a reference point whose elevation we set. So let's say I am doing survey over here. I can use select one point, which is usually the lowest one, and I can give it an elevation of 0. Then when I find out the heights of different points, they will be from this reference line, which has a height of 0. And whatever height difference between these, so these points will have values greater than 0 if they are above the point, and if they are below the line, they would have elevations in negative. And usually this reference is used as a conventional one, which is usually the mean sea level. So if I'm doing survey in Pakistan, uh, the water level near Karachi, that would be at an elevation of 0. And as you start going north, so your elevation would keep on increasing. And you must have heard the figure that in northern areas of Pakistan, they have different heights of mountains, this much feet in thousands, or this much meters. So if those mountains are at this much height, there should be a reference, and that reference is usually the mean sea level. So that is where you start from. So in survey as well, we use that reference level. But for executing localized project, you can introduce your own reference level, and then by using your instrument, you can find out height difference between different points.